Everyone to this edition of the CSIA Partner Technical Webinar Series. My name is Jeannie Rosen. I'm the Marketing and Communication Director for the Control System Integrators Association. I'm happy to introduce our partners and webinar hosts from Evans Consoles. This webinar is titled Control Rooms, Enhanced Value to Clients and Margin Opportunities for CSIA Members. CSIA is pleased to co-sponsor this educational webinar with our CSIA partner members and valued industry proponents. We are grateful for their support of CSIA and the profession and industry of systems integration and automation. We are particularly pleased they are providing this technical education presentation to the system integration and end user community. Next slide, please. For those of you who are unfamiliar with CSIA, we are the only trade association focused on advancing the system integration industry. Our vision is to ensure that manufacturing and process industries everywhere have access to low-risk, safe, and successful application of automation technology. To accomplish this, CSIA supports system integrator companies in becoming better businesses. We offer guidance to improve integrator effectiveness with our best practices and benchmarks manual, an open forum to connect and learn from other companies, and opportunities to market within the industry. As our members continue to improve their management skills, they can begin to work toward becoming CSIA certified, an industry standard in business excellence. Next. CSIA membership offers members access to resources needed to attain their business goals. These benefits include networking opportunities at the annual executive conference, which happens to be taking place next week in Fort Lauderdale, marketing toolkits, and educational materials. We also bring you the Industrial Automation Exchange, an online buyer's guide and community that connects end-user clients with system integrators, industry suppliers, manufacturers, and process companies together in one convenient location. These are just a few examples of how CSIA can improve your business, with CSIA certification being the recognized seal of approval. Next. CSIA certification demonstrates commitment to meeting the highest standards for integrator business and management. Successful system integration businesses combine technical proficiency with sound business practices. In fact, clients are now seeking integrators with a CSIA certification alongside of an ISO certification. Next. And what does this mean to our supplier and systems integrators and your clients? CSIA certification focuses on business practices, whereas other certifications traditionally focus on quality and technical abilities. Clients will recognize your commitment to industry standards and business acumen when they see that you are certified. Certification also increases the probability of your technology being well represented and greatly reduces the risk of project failure. Next. The CSIA Industrial Automation Exchange is the premier automation supplier guide featuring control system integrators who provide industrial, manufacturing, and process automation solutions. This is the first place to search for industrial automation answers and for clients to research technology teams to implement their next automation integration project. Clients can easily filter to integrators and suppliers based on industry, specialty, products, or location. Clients can search for specific products and choose a supplier's recognized or certified integrator partner. For integrators and their partners, it's a place to market their expertise. Clients will find white papers, case studies, capabilities, contact information, and engage in conversation directly with CSIA members. Content posted on the exchange often ranks higher than content posted on your .com or blog, even LinkedIn or other platforms. Any company in the automation arena can create a free profile on the exchange. Next. For more information on CSIA certification, membership, or how to participate in the exchange, contact CSIA at 800-661-4914. Thank you for joining us today, And for those of you attending the CSIA Executive Conference in Fort Lauderdale, we will see you next week. I will now turn the webinar over to our hosts from Evans Consoles, Matko Papic, Chief Technology Officer, and Sean Way, Industrial Business Development Manager. Thank you, gentlemen, for hosting this webinar. Take it away.
Well, thank you, and good morning, everybody, or good afternoon, depending on where you are in the world. So what we're going to do is talk a little bit about some best practices and general thoughts on control room design. If I could ask that you hold your questions till after the presentation. I mean, you can type in your questions, and some of the folks that are monitoring will keep a record of them, and we will answer them towards the end of the presentation. So our goal today is really to have a general control room discussion, and providing an opportunity for you as a CSIA integrator to really engage your customers beyond software systems and really be able to talk about control room design and the implications it has. And quite frankly, it's an opportunity for you to explore additional revenue streams with your customers. So what we want to do is share some of our insights and help you plan your control room of the future. We look at things like influence of technologies, what others are doing, what some of the current market trends are, what we see as the future trends, how certain customers are leaving their comfort zones and referencing what other industries are doing, some of the opportunities, pitfalls, best practices, and most importantly, risk mitigation, which is a key factor within control room design. Just briefly about Evans. Evans is the world leader in designing, planning, and manufacturing and implementation of mission-critical facilities. This is a pretty picture that we like to show. This is of the Kennedy Space Center launch control room. And what we do is we take a comprehensive approach in looking at how to design a mission-critical operating environment from the conceptual phase all the way through to implementation. We're very much a global company, and that is key because we are able to support our partners around the world. So no matter where the project is, we do have a global presence. And one of the things that Evans is best known for is being able to provide local support in different regions of the world while still providing a very consistent solution. One of the reasons that we have developed a significant amount of expertise in the control room area is the different market segments we play in. Evans designs and builds control rooms for various market industries, ranging from intelligence, public safety, military aerospace, oil and gas, air traffic control, electrical, and what happens during that process is we do get exposed to a lot of technology and different trends within the industry, which allows us to gather those best practices and really be able to see what's out there and how it's being applied in different control room applications. In terms of our business, we're structured into three major groups. So there's the control room design group, which really looks at the front end of control room planning. We look at the room design, operational planning, ergonomic assessments, things like live cutover planning, which is a very common trend in terms of being able to plan and execute a live cutover of an operation while it's still producing output, or needs to be done in a very, very limited time window, think 1 or 2 weeks. We do project management, traffic flows, and then we have the core part of the business, which is the product manufacturing, which is the consoles, custom millwork, technology tables, power and data solutions, specifically designed for the 24/7 control room environment. And then we have a construction and installation team, and that ranges from installations of product to construction services within the control room. Electrical and plumbing, raised flooring, lighting and acoustical, and we do this specifically for control room environments. So we're not a commercial construction company. We very much focus on control rooms themselves, and in particular when we're talking about modernize or upgrading an existing facility. Our market approach, we approach the market by working either directly with end users, typically in a very early stage when they're talking about operational planning tasks and how they want to structure a control room. We will work with architectural companies who will hire us as a subject matter expert in control room design to help them complete the overall package, design package of a facility. We'll work extensively with system integrators, large and small, depending on the size of the project opportunity. We'll work with general contractors who could be in the execution part of a project, EPC providers, and control room partners. So we do have very much a mixed approach to market. And again, this leads to exposure and a broad understanding of how the engagement and execution process of control rooms works. So to get into the presentation, you know, the role of the control room, you know, as we look at it is, you know, you've got several processes that influence the control room. You have kind of with information coming in, you've got process control systems such as DCS, SCADA, etc. You have process requirements in a given facility on how it needs to operate, whether they're regulatory or business practices. And these things have to be interpreted by a control room. And, you know, I label those as rigid, meaning it's, you know, it's unlikely to influence or change DCS or SCADA systems or process requirements. The control room needs to be flexible to be able to adapt to them adequately and provide the best possible space for the operator, because at the end of the day, you know, the system of control and being able to monitor a mission critical operation really is all about the operator, because they have to be able to perform at an optimum level. On the other side, there's other rigid limitations within a control room. You know, you've got physical infrastructure, so if you're you know, constrained by an existing building, operational requirements by the operator, architectural requirements, etc. What this really leads to is that the control room has to be able to adapt to these different rigid requirements that may exist. And one of the things to think about is, you know, focusing purely on the operational aspect of a control room can have really bad effects on the operation. You know, today we're starting to see technology really increasing the flexibility and integrating incompatible control mechanisms into one, and we'll get into that a little bit later. Looking at control room design early on in the process is very beneficial because it helps mitigate risks, but it also significantly can reduce costs because, you know, early planning and being able to understand the implications of the control room design on the operations can be very, very beneficial. You know, things to look at is, you know, what does a control room function like in normal operations, in upset process scenarios, what's the emergency operation, and looking at the continuity of operation. These are critical factors to be considered. I like this picture as a bad example of, you know, how to structure an operation because, as you can see, things are not well thought through. They're sort of just put in place. There's cables everywhere. The displays are not positioned properly. So taking all of that into account is vital. When we look at the different factors that kind of influence the design of a control room, you know, there's things like, there's the obvious ones, you know, there's ergonomics, and a lot of people talk about ergonomics, but, you know, there's IT to think about, you know, how is data being managed? Is it local? Is it remote? Do you have the adequate channels to get to the control room? You know, the needs of the technology integrators. So what are their needs in terms of server room placement, heat generation? What kind of infrastructure do they need outside the control room, within the control room, communications? What is the operational model of the facility? You know, what is the management mission, the facility mission? What is the technology that's available? The electrical and network infrastructure, so understanding where it is, how it is supplied, and how it is going to be distributed. Space utilization, understanding the people. You know, what is the profile of the folks working within the operation? And then also looking at facilities because they have their constraints. These are all stakeholders that are important to consider when you're looking at the design of a control room. And, you know, I have this simple kind of chart that talks about, you know, at a very basic level, what does a control room do? You know, you've got essentially an operator that's integrating with technology. And in some control rooms, you might have 2 or 3 or 50 or 200 operators that are all interacting with that same technology, whether it's a DCS system, SCADA, or security monitoring, or whatever it is. Then you have the interaction between operators. And typically within a control room, you also have a management level or supervisory level, and then you have some immediate outside stakeholders like IT support or building maintenance. All these folks are tasked with ensuring that the control room operation is running correctly. Then you have outside stakeholders. So if you think of a refinery, you have folks on one end who have certain requirements to the control room, whether it's tag in, tag out, whether it's service maintenance, and then you have people on the other end of the process who are being dispatched to address a certain issue. So all of these folks have a requirement to communicate with each other. And when you start looking at the broader aspect of a control room, this really is a complex and unique process for each environment. We always like to say that no two control rooms are the same because, each of them has very specific needs operationally and from a space standpoint, so you really have to take all of it into consideration. And so as a result, you're seeing some images of just different room layout options. All of these rooms actually have a same process control function, but they're designed radically differently. And the reason they are is because they're tailored to a specific need and requirement. So there's no real out-of-the-box solution. And what you need to think about is the flexibility to adapt. And with that slide where we talked about rigid constraints, that's what we really want to be able to adapt to within a control room environment and create the best possible scenario. Some of the things that we look at is not just the control room, but also what's around the control room. So what is the control room interacting with? Where are the break areas? Where are the washroom facilities? Where's the server room? The emergency operations center, do they have access to the control room or not in an upset scenario? All of these things are important to consider as part of the sort of design process. A lot of folks talk about ergonomics, and ergonomics is becoming more and more predominant. And the thing with ergonomics is it's not an exact science. It's really heavily influenced by operational conditions and needs. But at the end of the day, what it should focus is providing users maximum flexibility and adjustment in how they interact with technology. I like this picture down here. You see the two air traffic controllers. One of them is sitting back with their feet up. The other one is kind of sitting in a more normal posture. The idea here is to be able to provide an environment that allows for both scenarios to happen so that you're not constraining somebody into a fixed physical position during their shift. When you look at the two images on top of the screen, nobody really sits like the person on the right-hand side because it's just too rigid. You have to be able to change postures and adjust. But the other thing about ergonomics that most people don't recognize is it's not just about physical ergonomics, which is kind of your posture and how you can reach and see certain things in your immediate environment. There's also a very significant aspect of cognitive ergonomics, and that is the ability of a person to process information cognitively. Think of asking questions like, how many alarms, both visual, audible, do they have to interact with? How many conversations, phone calls, within a shift or within responding to a certain process? And what's critical there is to be able to understand, as part of operational planning, does this person have enough capacity, in responding to a certain scenario to process all of this information effectively and not miss alarms or not be able to communicate adequately with others within the process. So cognitive ergonomic review is vital within the control room. And then there's the organizational aspect of ergonomics, which really looks at, the structure of communication, human interactions, positioning of supervisory positions versus operators, who needs to see and talk to who within the control room, what are the visual cues, and how is the whole operation structured. This is also where we look at normal versus upset scenario, because that has a significant impact on the control room. Some argue that a control room is really designed for the 1% of being able to respond to that critical upset scenario. So how do you address ergonomics within a control room to be able to consider all these factors? Well, it's a step-by-step process, but generally speaking, the best way to address it is to start with the operator, knowing all of the operational needs and requirements, understanding the technology that they're interacting with, and you start by placing the equipment that the operator needs to interact with in the best possible position for the operator. And here you kind of see it floating in the air. And the reason for that is to establish the proper operational position. It's only after that that you actually build the infrastructure to house that equipment. So generally it's a console, and so the idea is not to try to have the operator conform to something out of the box, but rather tailor the console itself to their need and the ideal equipment placement. And then from there, you start working outwards and looking at the technology and the ergonomics of the position. So in this case, you can see that it has a sit-stand application. So the operator can, be seated or standing. You can have a split input platform or not. So there's just different approaches. And then from there, you start looking at interactions and clusters within the control room. So who needs to see who and talk to whom, and sort of working your way out, understanding the core constraints. A big part of ergonomics is the audiovisual side, and it's not just ergonomics, it's also operational. Now, AV technology is evolving significantly over the last few years. It's really gone from being a visual pretty tool to a critical aspect of operations. And a lot of people, when you ask them what's AV, they always think about these large, big video walls, but really that's not what it's about these days. There's a very big differentiation between hardware and software. And the reason I say that is because the hardware today is becoming more and more commoditized. It's the software that's becoming the critical element. And the AV system needs to really be flexible to cater to the operation. One example, you can see kind of the upper image of the control room. You can see the different types of displays that are being used. You have kind of a 24/7 wall that's monitoring. In this case, it's a SCADA grid, but you also have peripheral information walls that utilize different types of technology, but it's all brought together by being able to switch and manipulate content. And this is where, this is a real kind of emerging trend within control rooms, is to be able to have custom layouts for each operator based on their preferences and access rights. So what information is seen either on the operator position or common display is becoming more and more flexible, and it's able to bridge multiple technologies. And the reason is because they're able to pull content without actually interrupting the core operational needs of each software, of each platform. And that's a big difference from about 5 or 10 years ago, where these platforms and the way they're viewed are becoming more and more agnostic. So considerations on the AV are critical. Also, looking at a control room, what kind of environment do you want to build? Do you want to have AV as a collaborative local display? And you can see that in the bottom left-hand image, where you have an operator, and then when the need arises, there's collaboration at the local control position, versus on the upper right-hand corner, you see more of a traditional approach where all of the different operators are viewing a common display wall. Now keep in mind, there's some customers who like to put in a common view simply for marketing and promotion services. They just want their control room to look great. Others have a very key operational interest to be able to have a system like that. So it's things to consider and questions to ask. This is an example of sort of the localized collaboration station. We're seeing this particularly in pipeline control, in some of the refinery applications where you have kind of localized common viewing, and with the ability to easily switch and provide content, you can pretty much configure this common display to whatever you want with a click of a mouse. And it allows people to huddle around and address a specific issue. And we're starting to see this as a more significant emerging trend within control rooms. So you can see that really this station has two separate functions. One is tailored to the operator, which is the lower row of screens. And the second one is the common display that can be adjusted in height, in depth, and all these different aspects to provide kind of a collaboration environment. This approach versus the traditional large cube display approach also provides significantly better cost savings and flexibility into the future. But also, the common approach is also still being utilized. So when you look at this control room, you really ask the question from an ergonomic standpoint, well, what is the benefit of this wall? Well, when you actually kind of peel back the onion and understand the operational side, the wall is really not used by operators at all. They're sitting kind of in the first two rows, and yes, it could be a general situational awareness tool, but what it is used for is the back management and supervisor level that are actually looking at an overall view of the function of the operation. So they could have a PI historian, or they can have different types of display information on there that's telling them the efficiency of the process. And then the third aspect is management. What this particular control room does is its products are promoted to some very high-level customers who want to see the integrity of the operation. So you can see the viewing gallery on top, and they have a vested interest to kind of display the function of the control room adequately. So each control room is unique. Looking at interactions and traffic flows, this is a critical element, particularly when you're talking about access, security, who can be within the control room environment. One of the frequent questions we get asked is, should management have access to a control room? In a lot of cases, the answer is no. You want management to have separate access into an emergency operations center, but not actually be able to go into the control room, because they want to have the operators focused on resolving the issue at hand. So doing a proper interaction and traffic flow study is critical, so that you can in advance determine how many people would be in the control room during an upset event. Lighting is one of those things that's becoming more and more prominent in control room design, particularly as LED technology evolves. It's a key element in mitigating operator fatigue and just creating a better environment which promotes alertness, etc. One of the things that's really being researched extensively is circadian rhythms. So our body does not respond the same at 2 o'clock in the morning versus 8 in the morning. And with research and some lighting zone technology that's been developed, control rooms can now really mitigate that by changing the ambient lighting and really being able to kind of, for lack of a better term, trick the body into adapting the environment to the normal circadian mode that it's in at a given time. So obviously LED technology is big. Things like using indirect fixtures, having the ability to have dimmable lighting, having the correct material selections, and having adequate individual task lighting to offset the general control room illumination. It's a very important aspect of control room design that should be looked at. And this just shows you an example of kind of integrating lighting both at a personal level. So these LED lights that are on the console positions themselves, they can actually be tied into process alarms. So each station can illuminate in a different color, and it can just be another layer of visual alarms that's easily visible to the entire control room, especially to supervisory staff if there's an incident. Acoustics are very similar. Often you'll walk into a control room, and because of the way they're shaped, there's going to be a significant amount of bounce and reverberation within the space. And with the evolution of display technology and having such a huge area of flat displays in front of the operators, the bounce really needs to be considered within the control room. And when you look at it, this is why it's important to understand interactions, traffic flows, where the break areas are. And doing the acoustical design is both relevant to the room itself, where you can see acoustical treatments on the wall, and you can see the lower images make it a lot more aesthetic and kind of conform to a specific client. And then also the product itself, how is it clad? You want to try to bring in maximum absorption, look at the appropriate carpet tiles and ceiling tiles that have the adequate NRC rating to be able to absorb a lot of that bounce and noise within the control room. And again, this is just an example of, where you have a building constraint. In this case, the building was built in the 1800s, so it wasn't going anywhere. But being able to treat the ceiling and the carpet and the walls in such a way to provide maximum absorption, and because these operators communicate a lot with external stakeholders, there's a significant amount of noise. So being able to mitigate that within the control room design is very important. The next area I want to talk about is technology. So what really influences the life of a control room? Most control rooms you want to be able to operate between 10 and 20 years in average. So there's the obvious, the quality of the build, but then the ability to adapt to changing mission requirements and the ability to sustain growth and technology change. And really, you know, quality of build is a given. That's something that's fairly easy to ensure by, you know, making sure that the providers are all reputable and have good kind of products and warranties. But the two areas that really need to be thought about early on is the ability to adapt to changing mission requirements and technology change, because those are the two things that are most likely to evolve, especially in today's day and age. So, you know, this is typical kind of Moore's law of disruption. You know, technology change is obviously outpacing any other type of change within the environment. And what this really means within a control room is, you know, if we take that span, you know, of, let's say, getting a control room in 1990, this is the technology that was purchased. And you can just see how technology, monitoring, AV, lighting, everything has changed over those 25 years. So it's really being able to have product platforms that are flexible and to be able to have kind of design thought processes that are going to cater to future change. You know, as an example, you know, when you look at a typical operating position, you can see that this one has kind of a row of monitors, it has CPUs. It's very likely that that's going to change over time where, you know, the CPUs might go to remote, so you want to have the ability to remove them, to strip the structure, replace the single row with large screen displays, replace the keyboards with a touch screen, be able to add large panels. So it's being able to think about the product flexibility moving into the future. So because one of the main reasons control rooms don't change is because it's too difficult, and therefore the customers lose out on efficiency. If you can make the change quickly and cost effectively, then the end user can continue to, if you will, reap the rewards of being able to implement newer technology, more efficient technology quickly and at a low cost. One of the things that always surprises us is raised flooring, is how many control rooms don't consider it. A lot of them, especially those that are built, you know, buildings that were built 30, 40, 50 years ago, don't have adequate raised flooring. You know, our recommendation always is to even use a low profile floor, as you can see down here, and they can be, you know, as low as 3 to 4 inches. But it still gives you flexibility to be able to reconfigure the space down the road and really have adequate cable management. For a lot of people, this is a given and they know it, but it's surprising how many end users don't understand the importance of using this. The other part that's really changing in control rooms is modular power and data. So, you know, the picture on the upper left-hand corner, you can kind of see the mess. The cables can always be under the floor. What's really evolving within the control room is modular power distribution. So you can see here on the right-hand image, this is a modular power distribution system, and each of these carries a 320 amp circuit to be distributed across the room. And what that allows customers to do is essentially be able to run all of their power distribution as UPS 1, UPS 2, and dirty power within one shielded cable to anywhere within the control room. And you can see in this example where there's a raised floor, you can run the power distribution systems easily to each operator position. Where there's a steel floor, in this case, you can actually run the power distribution system to the beginning of a console and then run the rest of the distribution through modular units. So you don't really need a raised floor to be able to distribute the power. The advantage of this system is to be able to switch and move the positions around without having to do significant rewiring under the raised floor. And for those of you operating in North America, the additional advantage of this is a fully UL certified system, meaning that you don't need an electrician to do any of the work within the control room, which provides substantial savings, you know, in project execution. One of the other things that's really evolving is kind of flexible wall technology, and what that means is, you know, when you look at a space, and this is just an example of a completely open space, using modular walls and raised flooring really allows you to kind of adapt the space to a specific operational need for a certain period of time and then quickly be able to reconfigure. So you can see here where this wall is taken as an example where you can kind of start to build separate areas. The walls carry the same modular power and data distribution, And from there, you can kind of start to build functional enclosures within the control room. And the advantage of this is because it's not brick and mortar, it's very, very easy to reconfigure. So you can see how you can build out an empty space into a specific operational environment. And in this example here, this was a customer in oil and gas where the building was built as an open space, and then all of these different functional areas were achieved by designing dropped ceilings and movable architectural walls. So we were able to create specific operating areas within the environment that are also going to be very, very quick to reconfigure down the road. And then the last thing that I want to mention is the people. This is where there's a significant change happening. The workforce profile is changing significantly, as you're starting to see a lot more people coming kind of from university and the Gen X and folks retiring from different industries. But what the change is folks coming out of university, or if any of you have kids in high school right now, they look at a single screen, and this is just a snapshot of Windows 8, and they are now able to process information from a single platform and medium. So they'll be looking at one screen, and they'll be reading the news, watching a video, following Twitter, so multifunctioning within a given screen. And what's happening is that change is starting to come to a lot of process control and mission critical applications. So here's an example of a DCS system kind of in a conventional way, where you have kind of the operators in their 40s and 50s, looking at one screen for one specific information feed. You can see here there's 2 DCS systems covered by 4 screens, and then you also have 3 DCS keyboards and 3 auxiliary keyboards underneath the work surface for a total of 6. Where technology is moving is all of this information is being moved into this type of system, where all of the different displays are going into a dashboard type approach, and there is quite a few early adopters who are moving all of their keyboards into integrated touchscreen systems. Now, this is not an easy transition, and if you are acting as an integrator or technology provider, part of the challenge is getting control room operators to understand the technology and be able to transition to the change. So, part of what we do is we kind of talk to operators and understand what the risks, advantages, and disadvantages are. Now, not everybody is, ready to embrace this technology, but it is becoming more and more prominent because it just offers substantially more flexibility. This, combined with a very flexible audio-visual software system, really enhances the flexibility of the control room. And the last thing I want to mention is, how simple technology can be used to greatly improve the efficiency of an operation. So the video I'm going to show you is an example of the interaction between an emergency operations center and police and fire in the field. And this was taken during the floods in Calgary in 2013, where you had the EOC directing the evacuation of about 120,000 people because downtown was getting flooded. But what I want to show you is how to use a smart board, a simple smart board, as a communication tool. So you can see the EOC is making the decision to evacuate a certain area. As they're saying evacuate, with the proper planning and IT permissions, all of the folks that have the appropriate permissions in the field can see this information displayed on their handheld devices, and they can interactively communicate back with the emergency operations center, as you can see. So they're saying, hey, we need to evacuate this area as well. Also, they're using common feeds, network feeds, public feeds, to be able to gain real-time information and pictures from the field. So you can see the water rising, and they can say visually, instead of saying an address, they can say, evacuate the red and the brown building here, because the power systems are failing. So it's a very interactive additional layer of communication. We're starting to see this being used in refineries, where a problem with a process control hardware piece can be communicated via picture. Control room operators and others in a response center can pull PNID drawings to quickly identify what part needs to be replaced. So it greatly improves efficiency and communication. And again, this is a simple off-the-shelf tool that with the proper planning can easily be integrated into the system. So, in the end, kind of in conclusion, why is control room design important? Well, the obvious parts of it is it's a validation process to ensure conformance to standards. It's proper considerations of human factors, occupational health and safety, disability acts, involvement of key stakeholders in the process, and really creating the optimum operational environment. What is a little bit less obvious, and what sometimes folks overlook, is it really reduces the overall project risk. Early involvement very often means significant cost reduction, and it's a very clear identification of scope and components, so there's no confusion down the road. And it really helps to increase efficiencies, so resources, accuracy, safety, value add, and it ensures that both the technology and the operational needs within a control room environment are aligned. Moving forward, Evans can partner with you to extend your reach into your customers, because there's revenue opportunities there, including control room design, operational consulting, turnkey construction, console technical furniture, all these different elements that you can work with. So I wanted to thank you for your attention, and we'll take any questions that folks may have.
Muted.
So one of the questions is, with modular walls, how do you keep noise separate in each room? The walls themselves actually have acoustical properties, so they can be treated with different panels. So they can be, they can be high pressure laminate, they can be compact laminate, but they can also be lined with NRC rated fabric panels. So they actually can be very, very good for ensuring acoustical insulation within the room.
So if there's no more questions, this is Sean Way speaking. I just wanted to wrap up by mentioning that
Sean, there's more questions.
Oh, there is? I'm sorry, I can't see those questions for some reason.
Yeah. I'm just trying to scroll through them. So one of the questions was, aside from all the considerations you have to make in designing a room, is there a single guiding principle that you feel guides most of your decisions? To us, it's really trying to bridge the gap between the technology and the constraints and the end users. It's really being able to provide a solution that's effective and that in best way adapts to all the constraints that we talked about earlier, because again, the frustration in control rooms is there's things you can't change. You can't change the physical space, you can't change the DCS system, you can't change a lot of these operating requirements. So being able to ask the questions and have all the different stakeholders go through a process where they're heard and involved, we feel that it really helps kind of set the direction. And the other thing we find when we do workshops and things like that is we get substantial end user buy-in. And that is critical because, going through the process of validation, when all of the stakeholders are involved, it really helps them feel like, they've been heard and they've been kind of included in the decision-making process. So I'm still trying to browse through these questions. Phil or Eric, if you're seeing any of these, please let me know. So far, I've seen 2. Okay, it looks like we had just the 2 questions that I can see. So Sean, Take it away.
All right, thanks. I just wanted to wrap up, let everyone know that we'll be attending the CSIA Executive Conference next week. I will be there. Evans is participating in the exhibitor night on Wednesday, so feel free to come by and see me. I'd be happy to chat with you a little bit more about some of the products and services and offerings we have. Also wanted to mention that we have a very broad base of experience within our sales team distributed across the globe. We have 17 sales managers across the United States that would be happy to meet with any of you and your teams. If you're interested in setting up further presentations or some lunch and learns, maybe we'd be happy to come in and talk to you either about this or maybe a more targeted discussion. And wanted to wrap up by saying that, you know, we're very flexible in the way that we approach our projects. So if you have a customer that you think might be interested in doing some work in the control room, we'd be happy to join you either as a partner or behind the scenes as a subcontractor to help you go in there and satisfy your customer needs. So feel free to reach out to myself. I'm not sure if my contact information was listed on this presentation, but it's certainly available through the CSIA Exchange website. And you can also reach us on our website as well. So hopefully we'll have an opportunity to meet some of you in Fort Lauderdale next week. And we'll wrap it up with that. Matko, I'm not sure if you had anything else.
No, I haven't seen any more questions, but again, I wanted to thank everybody for your attention and thanks for listening in, and hopefully we'll see you at the event. Okay. Well, thank you, everybody. We're going to end the webinar now, and again, thank you for your attention.